Hello everyone, this is Anurag Tripathi. I'm from Kanpur. I have done my masters in mathematics from Kanpur University. I've been teaching for past 6 years. In my teaching approach, I think it is good to reach to the each and every student in the class. Topic is gravitation. We are going to study about gravitation, how it works and what is the use of gravitation in our daily life. We have come across a lot of questions, or many of you wondering how the planets around the sun revolve. The planets are attracted by some great force that bind the planet in the orbit around the sun. So, what is this force? Newton has described the force very easily. When we leave two objects in the free space, they will attract each other. So, what happens when we leave two cars in the space? Will they collide? Yes, obviously, if their force of attraction is quite big and they are close enough, then they will collide. How? We are going to solve this mathematically as the Newton has done in his life. Let's see. This is an object of mass m1 and this is an object of mass m2. They are placed in the free space. They are floating. But when their force of attraction becomes greater, they will collide with each other or come closer because of the force that is known as gravitational force. Say, F is the force between the two objects. This force also depends upon the mass of the object. If the mass is greater, then the force also becomes greater. Take the example of two small balls and two planets. Between these two and between these two, which two objects have the greater force of attraction? You can easily say that the force of attraction between these two will be far greater than the two balls or two objects because these have greater mass. They weigh more than these two objects. So we can say that the force depends upon the mass. So the force depends upon the product of the mass of the two objects. Also, the force also depends upon one more thing, and that is the distance between the two objects. Take the case of magnet. Like in magnet, if we bring closer them, they will attract each other more fiercely. But when we separate them, after some time, their force of attraction becomes feeble. Similarly happening with the case of planet or the object. If the distance between the two of them is r, and if r is increasing, then the force of attraction is going down. And if r is increasing, then the force of attraction is going down. And if the distance between them is decreasing, then the force is going up. So we can say that the force is inversely proportional to the square of distance between them. So, after combining these two equations, we get F proportional to m1 dot m2 upon r square. When we remove the proportionality, we get a constant, that is k m1 into m2 upon r square. But our scientists have experimentally found that the value of k is F equal to g m1 m2 upon r square. This is the formula for gravitation, where g is known as universal gravitational constant. And if this is constant, it has a fixed value. Its value is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. This was force of this was gravitational force. What is the use of this in our daily life? Because of gravitational force, we stay on the planet. And because of the gravitational force, our planet stay in the orbit around the sun because our sun is enormous and it attracts the planets by enormous force and pulling it towards it. But our planets have much more speed, so they keep revolving around the sun and don't come into contact with the sun. I hope you enjoyed this session.